Good morning, students. So we have finished to yesterday's class castability, mentionability, and weldability. These are under the category of mechanical properties of the materials. Now we are moving to the another topic, that is engineering materials. These are all under the category of factors influencing while designing a component. Understood? Factors influencing while designing a component. So far we have completed up to the properties of the mechanical properties of the materials, right? Now coming to the engineering materials, we know already these topics, right? So the classification of engineering materials is presented in the next figure, and the properties and uses of ferrous metals are given in this table diagram. We know this diagram very well. Engineering materials, and this we have divided into two parts. One is metals and another one is non-metals. Under the category of metals, again we can divide into two types: ferrous metals, non-ferrous metals. In ferrous metals, they have contained iron. In non-ferrous metals, they don't have the iron, right? Ferrous metals, metals which contained iron, uh, so that metals are called ferrous materials. Metals which does not contain the iron, those metals are called non-ferrous metals. Okay. Now coming to the ferrous metals, again it is converted into three types based on the carbon content. We know already. uh, those are steels, wrought iron, cast iron. So these ferrous metals are divided by three types based on the carbon content. Understood? So engineering materials divided into two types: metals and non-metals. Metals again divided into two types: ferrous metals and non-ferrous metals, right? And ferrous metals again divided into wrought iron, steels, and cast irons. Okay. So the following, the choice of materials depends upon the particular applications. Okay. The In the design point of view, we have to select the material. So that choice depends upon the applications. What are the applications we are using based on that material? Okay, the following factors are mainly considered while selecting a material for a particular application. Okay. So one is service requirements, and second one is fabrication or manufacturing requirements, and third one is economic considerations. Okay, these three factors influence the choice of materials. Service requirements. So what are the service we are using by providing that material? And manufacturing requirements. So, to manufacturing a product, we need some manufacturing methods. So, some of the materials are not doing well by using a particular method. Okay, not manufactured by using a particular method. So, we have to consider these requirement also, and economic considerations. So with some materials we are getting good benefits, but the cost point of view, it should be more economical, right? So for that reason also we have to keep in mind, right? So these 3 points we have to keep in mind while selecting a material: service requirements, fabrication and manufacturing requirements, and economic considerations. Okay, so before this topic, we are already discussed that machinability, weldability, and castability. Okay, So what are these things? So based on the material, some of the materials are easily machinable, and some of the materials are easily weldable, and some of the materials are easily castable. Okay, so this point influence in that only. So fabrication and manufacturing requirements. So for some particular material, it is easily getting machinability, but it does not getting the weldability and castability. So based on the manufacturing requirements also we have to keep in mind, right? So service requirements, manufacturing requirements, and economic considerations. So these three things we have to keep in mind while selecting a material, right? So some of the examples we are observing here. So let me explain one. Metals properties uses. So one of the high carbon steel, we can call it as HCS. The properties of this high carbon steel is it is very harder material, less tough and ductile than medium carbon steel, most costly than medium carbon steel. Okay, we are mentioned here the cost also most costly than medium carbon steel. So where we are using these high carbon steel materials: hand tools, shear blades, coil springs, drills, taps, ball bearings, and wear resistance components. Okay, so this is the metal and properties and uses where we are using these materials. Uh, in the same way, cast iron, gray cast iron, right, and spheroidal cast iron, malleable cast iron. Okay, but our subject point of view, these are all very important, the properties and the uses and where we are applying these materials. Okay, and wrought iron, steel, mild steel, medium carbon steel. Okay, where we are using wrought iron, train hooks, railway couplings, lifting chains, agricultural equipments. Okay, these are all you have learned in your engineering materials subject. It's coming to the manufacturing processes. I have already told you the machinability, weldability, and the castability. From the drawing made, this is the basic step for while designing a product. From the drawing made, the product is manufactured at a reasonable cost, right? So before actual design calculations, it is necessary for the designer to decide the manufacturing process to be used for processing the material. Understood? I have already told you, before actual design calculations, economical calculations, it is necessary for the designer to decide the manufacturing process. Which manufacturing process is it is the material will be manufactured. It is అంటే దానికి ఎప్పుడైతే అది ఈజీగా మ్యానుఫ్యాక్చరింగ్ చేయబడుతుందో అండ్ ఇంకెలా చెప్పొచ్చు అంటే సో ఆ పర్టికులర్ మ్యానుఫ్యాక్చరింగ్ ప్రాసెస్కి ఇది ఈజీగా గెట్ ఇన్ అవ్వడము అలాంటివి వీ హ్యావ్ టు కన్సిడర్ వైల్ డిజైన్ క్యాలిక్యులేషన్స్ అప్పుడు, రైట్? సో ఇంతకుముందు మీకు చెప్పిన కాబట్టి, సో బిఫోర్ యాక్చువల్ డిజైన్ క్యాలిక్యులేషన్స్ ఇట్ ఈస్ నెసెసరీ ఫర్ ది డిజైనర్ టు డిసైడ్ ది మ్యానుఫ్యాక్చరింగ్ ప్రాసెస్ టు బి యూజ్డ్ ఫర్ ప్రాసెసింగ్ ది మెటీరియల్. So the designer must also consider the facilities available for processing the material which we select. The designer must also consider the facilities available for processing the material which we select. Also, we have to we have to identify the facilities, uh, if these facilities are available or not. So first point ఏంటి, manufacturing process లో మనం ఏ మెటీరియల్ ఏ ప్రాసెస్ కి ఇట్ ఈస్ సూటబుల్, దిస్ మెటీరియల్ ఏ ప్రాసెస్ కి అయితే సూటబుల్ అయితే అది సెలెక్ట్ చేసుకుంటున్నాం. అండ్ నెక్స్ట్ ఏంటి, దీస్ ఫెసిలిటీస్ ఆ పర్టికులర్ మ్యానుఫ్యాక్చరింగ్ ప్రాసెస్ కి ఫెసిలిటీస్ అవైలబుల్ ఆర్ నాట్ వీ హ్యావ్ టు చెక్, రైట్? And the various routes of manufacturing processes for converting raw material into finished product are shown in figure. So we have number of ways that we have observed in this diagram. Okay, so observe here the first, the raw material is coming to this side. if we are melting the raw material, it is goes into the liquid state. So the liquid state means we have to manufacture with that liquid state by using the casting. Understood? So the raw material is converted into liquid molten metal. That molten metal is again converted into a solid material by using the method of casting. Right? If any unwanted material is present after the casting, we are going to the machining operation. We are using some machining operations with some of the machine tools and removing the unwanted material from this casting product. After the final product is coming, after the final product, we will send this machining to the assembly, right? After the assembly, the product will be finished product. Okay, so this is the first step: molten metal into casting, casting to machining, and assembly. Now, coming to the middle one, that is billets or bars, plates, etc. The raw material is converted into here. Some of the materials like billets, bars, plates, etc. These millets, bars, plates are manufactured by the method of metal forming. Some of the metal forming, drawing, deep drawing operations, extrusion. Okay, these are all metal forming operations as we have learned in our first year. Okay, after the metal forming, any unwanted material is presented on that finished some of the product. So we are going to the machining and removing the unwanted material and send it to the assembly. After the assembly, the finished product will be come, right. Now coming to the another step here, metal powders, right. The raw material is converted into metal powders, right. That metal powder is converted into powder metallurgy. With this powder metallurgy, we have some of the methods, sintering and one methods. With that methods, the product will be finishing. Final product will be finishing, and it is sent to the assembly, and the finished product will be come. And here observe heat treatment process. After the casting, some of the methods, some of the materials needed machining, and some of the materials needed heat treatment. So after casting, we can send it to the heat treatment process. After that heat treatment process, it goes to the assembly, right? And here also, after the finishing of powder metallurgy, this material is going to this heat treatment. After the heat treatment, it is coming to the assembly. After the assembly, we are getting the finished product. Okay. So this is the various routes of manufacturing processes for converting raw material into finished product. So one is liquid state metal, and the second one is bars, plates, etc. And the third one is metal powders. Okay. The choice of the most economical manufacturing methods depends on materials to be used. Right? We are observed in the previous slide different methods. So the choice depends upon the economical method and materials that depends upon the materials to be used, shape and size of the component, type of production, accuracy and surface finish. With the powder metallurgy, we are manufactured only small products. Okay, with the casting only, we are we are producing large size products. Okay, so here the shape, size and type of production, accuracy and surface finish depends upon the various manufacturing methods. Most economical various manufacturing methods, right. And coming to the surface roughness, whatever may be the finishing process used, we have different finishing processes, right? Grinding, right? And boring, reaming, these are all finishing processes. So whatever the finishing process used, the surface can never be absolutely smooth. Surface roughness is due to action of cutting tool, vibrations in machine tools and other machining parameters. So these are the factors influencing the surface roughness. The surface roughness is due to the action of cutting tool, vibrations in machine tools and other machining parameters. So the degree of surface roughness controlled, must be controlled and maintained, right? In assembly this is played a vital role. That's why we have to maintain the degree of a surface roughness, because surface roughness must be controlled and maintained, because decrease in roughness minimize the friction, wear, and also improves the performance of the product. So for that reason we have to maintain the surface roughness. If we are decreasing the surface roughness, we can minimize the friction and wear and also improve the performance of a product. The fatigue strength of parts is greatly increased with the decrease in surface roughness, right? Fatigue strength where we are getting where we are applying continuous load, right? Where we are applying continuous load, there the materials are going under the fatigue. The materials which resist the fatigue, the material so that material is having fatigue strength. So the fatigue strength of parts is greatly increased with a decrease in surface roughness, because the materials are continuously acted. For that reason, uh, if we are decreasing the surface roughness, the fatigue strength of the parts also uh, increases, right? So these are the some of the surface roughness values. So range of surface roughness by various manufacturing process. For sand casting, we are getting 5 to 50 microns. Permanent mild casting 0.8 to 6.3. Die casting 0.8 to 3.2. High pressure casting 0.3 to 2. Hot rolling 2.5 to 50 microns. Forging 1.6 to 25. Extrusion 0.16 to 5. Flame cutting, sawing and shipping 6.3 to 100. Right? Radial cut off sawing 1 to 6.3 and hand grinding 6.3 to 25. Disc grinding and filing, right? So 1.6 to 25, 0.25 to 25. So these are the some of the values: planing, shaping, drilling, turning, and milling. And while doing these operations, we are getting this surface roughness value, and based on our final product and based on our assembly, we have to reduce this surface roughness values: boring, framing, broaching, and hobbing. Okay, surface grinding, cylindrical grinding, horning, lapping. Surface grinding is having 0.063 to 5 microns, cylindrical grinding and horning, lapping, these values are. And polishing, burnishing, super finishing operations. Okay. So representation of surface roughness, we know already how we can represent the surface roughness, because we, in machine drawing also we have measured this surface roughness, and production drawing also we have measured the surface roughness. How the symbol is used in this surface roughness. The symbol used to designate surface roughness is the tick mark and horizontal extension line. Okay, the long leg and extension should be to the right as the drawing is right. So we don't have that explanation. Simply you have to observe this surface roughness value. It is a triangle shape and a horizontal line, and it is a leg value. Okay, we have mentioned this surface roughness value, right? So here we are measuring the machining allowance. Here this side we are measuring the machining allowance, and the top of this triangle we are measuring the surface roughness value, and at this horizontal line which machining method is used, we have measured, and sampling length of the direction of lay we have measured under this horizontal line. Okay, so these topics, these సింబల్స్ ఇప్పుడు మీకు ఈజీ ఏముందిలే అనిపించచ్చు, కానీ ఫ్రమ్ ది గేట్ పాయింట్ ఆఫ్ వ్యూ, అంటే ఆఫ్టర్ బీటెక్ మీరు ఎంటెక్ చేయడానికి గేట్ రాస్తారు కదా, అప్పుడు ఇవన్నీ ఈ సింపుల్గా ఇప్పుడు మనం ఏవైతే సింపుల్గా అనుకుంటున్నామో, దీస్ ఆర్ ఆల్ ప్లేయింగ్ ది వైటల్ రోల్ ఇన్ ద ఎంట్రన్స్ ఎగ్జామినేషన్స్. అండర్స్టూడ్? సో ఇది వన్ ఆఫ్ ద గేట్ పాయింట్ ఆఫ్ వ్యూ క్వశ్చన్. మెషినింగ్ అలవెన్స్ ఎక్కడ మెజర్ చేస్తాము, రఫ్నెస్ వాల్యూ అండ్ మెషినింగ్ మెథడ్. అండర్స్టూడ్? So in the figure representing milling length of 2.5 mm, the direction of lace is perpendicular to the surface. Measuring allowances is 1.5 mm, right? And the surface roughness is 3.2 micrometers. And observe here, the following symbols are used to represent the surface roughness on coin. Symbol, single triangle unte 8 to 25, then surface roughness value. Double unte 1.6 to 8, triple unte 0.05 to 1.6, 4 unte less than 0.0 to 5. Okay, and observe the different types of surface roughness measures. So here, if we are providing these two lines, it is for parallel, and if we are providing perpendicular symbol, it is perpendicular roughness. If we are providing cross symbol, it is for angular. If we are providing M, it is for multi-directional, and if we are providing C, it is for circular. If we are providing R, it is for radial. Okay, so based on the surface roughness, we are measuring the different types of symbols. Size, shape, and quantity. Okay, so this is also one of the factors influence while designing a component. The shape, size, and the number of parts to be produced largely determine the manufacturing process that can be used economically. Okay, the shape and size and number of parts to be produced largely determine the manufacturing processes that can be used economically. Larger quantity of parts having simple shape with the minimum possible size will reduce the cost of production. Understood? Large quantity of parts having simple shape with the minimum possible size. సో ఇప్పుడు ఎక్కువ క్వాంటిటీ మనం ప్రొడ్యూస్ చేయాలనుకోండి, ఓకే, అప్పుడు మనం సింపుల్ సైజ్ చూసుకోవాలి విత్ మినిమం పాసిబుల్ సైజ్. చిన్న సైజ్ అంటే పాసిబుల్ సైజ్ ఏంటి మినిమంగా తీసుకుంటే వీ కెన్ రెడ్యూస్ ది కాస్ట్ ఆఫ్ ప్రొడక్షన్. అండర్స్టూడ్? Effect of environment. So it is also one of the factors influencing the designing a component. Effect of environment also influence the designing a product. Due to importance should be given to the effect of environment. The most common environment encountered is the normal atmosphere. So some of the methods are easily reacted with the atmosphere. With that reaction, the properties of the products may be changed, and the products are undergoing to the rust or dirt. Some of the difficulties are produced on the products. So for that reason, effect of environment, where it is exposed, where it is used, also we have to keep in mind. Okay, some of the products have to be used where the heat content is more. Some of the products are used where the cool content is more. So for that reason also we have to keep some of the properties where it resists, the heat resistance is more or not. We have to select, or another cooling resistance or is or not, we have to select. Okay, so and some of the methods also going to the expose in the open atmosphere where where the moisture is present is more, it going to the corrosion. So with that corrosion effect, the materials properties may be damaged. So effect of environment also should be played the vital role. The two dissimilar metals should be separated with a non-metallic washer or gasket, and the exterior design should be such that it will not accumulate dirt. Durability and reliability also. Okay, reliability అంటే ఏమో మనం అనుకున్న పనిని ముగించిందా లేదా, అంతసేపు బతికుందా లేదా అని అర్థం. Durability అంటే how many days it can be survive. Okay, so the ability to resist the adverse effects of environment, use and maintenance with the progress of time is called durability. ఇప్పుడు మనం ఇంట్లో ఒక వస్తువు కొన్నాం, దాన్ని మనం వాడుకున్న దాన్ని బట్టి డ్యూరబిలిటీ ఉండొచ్చు, ఎట్ ద సేమ్ టైం దాని లైఫ్ ఉన్నంత వరకు డ్యూరబిలిటీ ఉండొచ్చు. ఓకే, ఏదైనా కూడా ఎనీథింగ్. ఇఫ్ ద టైర్స్, కార్ టైర్స్ ఉన్నాయి, సమ్ ఆఫ్ ద టైర్స్ 1 lakh kilometers వరకు చేంజ్ చేయాల్సిన అవసరం ఉన్నది. కొన్ని టైర్స్ ని మనము 40,000 kilometers కి చేంజ్ చేయడము జరుగుతూ ఉంటుంది, బేస్డ్ ఆన్ దట్ యూజ్ అండ్ ప్రాపర్టీ ఆఫ్ ది మెటీరియల్స్. ఓకే, అండ్ రిలయబిలిటీ, ఏదైతే మనం అనుకున్న టాస్క్కి రీచ్ అవ్వగలిగిందో, అన్ని రోజులు అది సర్వైవ్ అయ్యిందో, దాన్ని we can call it as a reliability. Reliability is the ability of a product to perform required function under given conditions for a specified period of time. ఇప్పుడు మనం ఒక డిజైన్ చేసిన ఒక ప్రోడక్ట్ని, ఆఫ్టర్ డిజైనింగ్ ఏ ప్రోడక్ట్ వీ హ్యావ్ సెలెక్టెడ్ మెటీరియల్, మెటీరియల్ కూడా సెలెక్ట్ చేసుకున్నాం, మ్యానుఫ్యాక్చరింగ్ చేస్తున్నాం, వీఆర్ యూజింగ్ ఇన్ ద అసెంబ్లీ, రైట్. ఓ మనం ఏమనుకుంటున్నాం, ఒక 10 years వర్క్ చేయాలనుకుంటున్నాం. ఈ 10 years అది వర్క్ చేసి రిపేర్ అవ్వకుండా ఉంటే ఇట్ ఈస్ హ్యావింగ్ దట్ రిలయబిలిటీ. ఓకే, సో డ్యూరబిలిటీ అండ్ రిలయబిలిటీ. So it may be measured, reliability, it may be measured as the probability of success at any time or the time for which a level of success can be assured. If the failure of the product is likely to cause serious injuries to the operators, durability and reliability in this instance become more important. And cost. We know already, while estimating the cost of a product, it is necessary to consider the quality of the product. So quality improve చేయాలని చెప్పి cost ను కూడా improve చేయొద్దు. Okay, quality improve అవుతూనే cost have to be reduced. The cost and quality are interrelated. Okay, so the cost of the product, if the quality is increases, cost also increases. So every time we have to moderate quality and moderate cost అనేది మనం యూజ్ చేయాలి. Increase in quality will have measurable increase in cost. The aim of the designer should be to design a product of acceptable quality at minimum cost. The life of a product is the length of the time or the number of times it is operated before failure. It is uneconomical to provide a longer life than is necessary because it increases the cost. Safety. All machines are potential danger to the operator and equipment. It is the designer's responsibility to take all responsible care to ensure that the design is in safe operation. Okay? Therefore, the designer must assess the need to provide adequate safeguards to prevent damage. So, these are all factors we have considered while designing a product. So, besides these above factors, the designer should also consider the standardization, assembly, maintenance, appearance, and market needs. Okay. అవన్నీ ఇప్పటిదాకా మనం నేర్చుకున్న ఫ్యాక్టర్సే కాకుండా we have to keep in mind standardization, assembly, maintenance, appearance, and market needs. Based on that market needs also we have to design. Unnecessary things మనం ఎందుకు, ఓకే నాకు డిజైన్ వస్తుందని చెప్పేసి మార్కెట్లో అవసరం లేకుండా కూడా మనం ప్రొడ్యూస్ చేసి మార్కెట్లోకి రిలీజ్ చేస్తే సో దానికి డిమాండ్ ఉండదు కదా. సో అది కూడా we have to keep in mind. Okay, so with this I am concluded this session, right? So up to now we have finished the factors influencing the design, right? Thank you.